First of all, welcome. Good to have you. Good to have you here tonight. We are going to talk through a few things that happen in the lab and then within the Virginia Tech Transportation Institute, which is where our lab resides. My name is Miguel Perez, and I'm associate professor at the Department of Biomedical Engineering and Mechanics at Virginia Tech, and I'm also a program lead for data engineering within the Virginia Tech Transportation Institute. I've been at I've been in Blacksburg over 20 years, and I've been at the institute for close to 20. Um, and my research areas are generally related to transportation safety as it pertains to mainly driver behavior, just understanding what drivers do and how they get into crashes and near crashes. And lately, I've been looking a bit more into different conditions that can impair driving, medical conditions that can impair driving, and how we can maybe address issues related to those. And I've been working with Jake, who's also on the call in the area of emergency vehicles. So, Jake, I guess you want to go ahead and introduce yourself.
Hi, everyone. My name is Jake Valenti. I did my bachelor's here at Virginia Tech. I graduated in 2019 with a degree in engineering, science, and mechanics. And I'm now a second year PhD student in the biomedical engineering program here. And as Miguel said, my dissertation work has started to take the shape around improving emergency response to motor vehicle collisions. So I'm really interested in trying to see how we can decrease the time it takes not only to respond to, but to decrease the time window between transportation of crash victims.
Okay, so what we have for you today are we'll start with a couple of videos and sort of a 3D tour of one of our facilities, so you have an idea of the kinds of things that we work with. Um, and then we'll just answer questions and we'll have a Q&A period after that. If you look down, run your mouse over the Zoom window, you'll see the Q&A window, and if you click on that, a little box will pop up. You should be able to type your questions there, and then we'll just address them as they come after the videos. So, and then the one thing actually I have to disclaim that the videos that you'll see were recorded before COVID, so you won't see a single mask in sight. But it is because they predate COVID.
The Virginia Tech Transportation Institute was founded nearly 3 decades ago and has rapidly progressed to become, by most metrics, the largest university-level transportation institute in the country. We house the largest group of driving safety researchers in the world, each dedicated to advancing transportation through innovation. Our researchers assess mobility, sustainability, lighting, vehicle systems, tire and vehicle performance, and active and passive safety across multiple users and vehicle types. Overall, our core mission is to save lives, time, money, and protect the environment. The Virginia Smart Road is a closed test bed on which we've conducted more than 22,000 hours of research since opening in 2000. The road has many features, including weather-making capabilities and the ability to replicate more than 90% of lighting found along U.S. roadways. The road is also equipped to support connected and automated vehicle research via dedicated short-range communications and cellular technologies, a connected vehicle-compatible intersection, and differential GPS base stations. The road was built to federal highway specifications and is monitored 24/7. The Global Center for Automotive Performance Simulation is an affiliated company of the Virginia Tech Transportation Institute. This world-class facility was unveiled in 2014 and provides revolutionary services for both vehicle and tire, including testing, modeling, and simulation. This center comprises 3 tiers: the National Tire Research Center, the Southern Virginia Vehicle Motion Labs, and the Virtual Design and Integration Laboratories. These initiatives collectively provide the full range of services essential for creating a more dynamic product through both virtual and physical development. The center is located in Southern Virginia and is less than about a mile from the Virginia International Raceway. The 10,000 square foot sled lab is housed within the Center for Injury Biomechanics of the Virginia Tech Transportation Institute. Located at Virginia Tech's Corporate Research Center, the lab features a 1.4 meganewton crash sled system. The sled lab is the only facility in the world with the capability to perform high-rate impact tissue testing and radiographic imaging. This capability allows for a better understanding of injury mechanisms, thus leading to the development of more robust mitigation schemes and protection systems. The Virginia Tech Transportation Institute recently partnered with several entities to unveil both the Virginia Connected and Virginia Automated corridors in Northern Virginia. These corridors allow real-world testing of connected and automated vehicles. The corridors feature dedicated short-range communications and cellular technology, high-definition mapping capabilities, and enhanced lane markings. We also provide access to the Virginia International Raceway, which offers hills, curves, and blind passes on both closed and public roadways. These testing environments are designed to supplement our connected and automated vehicle research. The Virginia Tech Transportation Institute houses 90% of the world's naturalistic driving data, requiring roughly 2.5 petabytes of storage. This data set facilitates nearly infinite analyses of real-world driver performance and behavior across numerous vehicle and driver types. These naturalistic data are used to help answer the greatest challenges facing drivers today, including distraction and fatigue. Recently, VTTI and its partners completed the second Strategic Highway Research Program Naturalistic Driving Study. This is the largest study of its kind and the largest known crash-only database available to date. Ultimately, this data set gives us a tremendous opportunity to help definitively determine the greatest driver risk factors. The Virginia Tech Transportation Institute will expand its naturalistic driving studies and continue to lead connected automation projects that support real-world development and deployment. We're also in the midst of creating a new Virginia Smart Village that will enhance testing scenarios across multiple automated vehicle platforms. The village will feature residential and suburban layouts with real and reconfigurable buildings, roundabout and stop-controlled intersections, automation-compatible pavement markings, hills and curves, and connectivity to the Virginia Smart Road through a secure, controlled environment. The world of transportation is not static, it's dynamic, and the Virginia Tech Transportation Institute will continue to grow to meet the demands of this evolving field.
Definitely have to say the technology. I get to see advanced technology years before it comes to market. We're always either testing technology that a client has sent us on the smart road or on the public highway, and a lot of times we're developing advanced technologies in-house, like virtual reality and conventional machine learning, as well as deep learning.
Absolutely, it would have to be the impact. I'm proud to work at a place that's known internationally as a force for good in the world. Over 1 million lives are lost each year on this planet in traffic-related accidents. At VTTI, the work I do is saving lives.
Definitely the work environment. I think what's really cool at VTTI is it has a perfect balance of support and autonomy, and lots of opportunity for advancement. 2 years here at VTTI is equivalent to 5 years worth of experience anywhere else. Every day, we're doing something different to make a difference in the world.
I see one question. It says, do you tend to work with civil engineers during these projects?
Yeah, we definitely do. It comes to play, civil engineers play a really big role in the transportation world, and they're definitely involved in a lot of the different projects that we do here. And for example, I know that amongst my year of graduate students that work at the Transportation Institute, one of us is very interested in the civil engineering aspect of transportation. So even though that's not their direct discipline that they study in, that is the main component that they're trying to involve in their research as well.
I will add, yeah, there's civil engineers are definitely involved. There's a group that there's a few different groups that mainly involve civil engineers. Some of them are related to pavement research, just looking at different compositions and different things that that could help pavement last longer. Um, there's also a few looking at traffic management, traffic operations. So some of that is related to traffic simulation, but just understanding um, what kinds of things you can do to improve traffic flows in certain situations, and what um, sort of manipulations are possible to help ease congestion, which is a big problem in many different areas. There's also the third aspect where civil engineering comes in is on the safety aspect of it, and then roadway design aspect of it. So there's a lot of work that has been devoted to coming up with guidelines that are used to design new roadways or remake, reconfigure existing roadways to make them safer and more easy to use. And so they're also involved in all of that. That said, however, so there's a lot of different fields that come into it. Industrial engineering plays a role in there as well. Psychology does as well. Computer science is also a very important aspect of it. We're starting to use more and more machine learning and machine vision types of tools. So we need people that are interested in all of those. And then biomedical engineering, given the potential for injury and fatalities. And so in those kinds of situations, biomedical engineering comes in handy. So it's a very, and of course, electrical engineering, all of them play a role. So one of the things I like about it a lot is that it is a very multidisciplinary environment, and on any particular project, you probably will be working with engineering, different kinds of engineers, and people that have different specialties. Okay, next one is, where do faculty get funding to do their research? And do undergraduates ever get to write grants to supplement faculty research? That's a good question. So we are mostly soft funded, which for those of you that don't know, it really means that we have to bring in research to cover our salaries. so it is very research oriented, and it is very much a funding rich environment. We're always looking for opportunities. We try to have a good split in the funding that we try to go for. So there's some portion that comes from the government, different agencies within the U.S. Department of Transportation. There's also a good segment of this that ends up being private industry. So if you're interested in going to industry when you're done with your undergrad, it's a good opportunity to be exposed to what kinds of research are going on in the industry. And the cool thing about that is generally you're working with things that are really cutting edge. They're not out yet, and you get to see them and see them and play with them before they're out in the real world. Um, and then I guess the third element of our funding, some of it comes from private research organizations or private foundations that are interested in this area, or on the government side from health related agencies, National Institutes of Health, Department of Health, and so on. In terms of undergraduates being involved, it is possible, and it does happen. Usually, it takes a fairly committed undergraduate to be involved at that level. Um, it is, writing applications for funding is relatively hard. There's a lot that goes into it, but it has happened that undergrads are really involved in a particular project, and they become involved in that part as well, which is a great experience to have.
So the next one is, how do mechanical engineering majors become involved in transportation? And so that answer is pretty much applicable to any type of engineering discipline or even other disciplines offered here at Virginia Tech. First step is to just start looking into faculty and research that you may be interested in participating in and reaching out to the point people that represent those projects and endeavors. That's how I originally met Dr. Perez. I reached out and talked to him about some of the research that his lab has done. But I know that from some of the other out of all the engineers that I work with at the Transportation Institute, it's a collection of all disciplines, and they all pretty much started that same way, just reaching out and looking for those opportunities to start with. And then once you're here, it's even easier yet to move around to find something that you're looking for.
And from the mechanical engineering perspective, I didn't explicitly mention them, but of course they're very much involved. There's a fair amount of fabrication that goes into this. There's a fair amount of system, I guess, development. We're doing a fair amount of work related to automated systems or automation systems, and so there's a lot of sensors, actuators, all that kind of stuff that has to be implemented, made to work in the right way, and so on and so forth. And then I think in some of the videos, you might have seen some of the target that are jumping out at people every so often. So we have a fairly dedicated team that is constantly coming up with new ways of creating those targets and make them move realistically. Um, One of the things we've observed over the last several years is that we used to have what you saw in the video, sort of this cutout that comes out and doesn't move, doesn't have any articulated joints. Well, by now the vision systems that are in automated vehicles are becoming sophisticated enough that they use motion cues, articulations in your arms and legs to recognize that you're a pedestrian. And so when we're trying to test those systems, now we need to make sure that our made up pedestrians or mock up pedestrians actually move like a pedestrian does. So that's another opportunity for somebody with a mechanical engineering background and all that. Within VTTI, we have a full fabrication shop. If there's something that you can think of that helps you make things, we have it, and play around with it. So it really is a good environment to practice a lot of the things that you'll be learning in your classes. All right, the next one is, do you have any co-op opportunities? Yeah, I would say there's a lot of different ways in which you can get involved as an undergrad. So if I don't know that we necessarily call them co-ops because we are part of the university, so I'm not sure that it exactly works like you would think in private industry, but we have summer opportunities for different projects for people to get involved in, doing different kinds of things. Some closer to the experimental work, some closer to the support for the experimental work. So there's many different ways to get involved in. There's also the opportunity to sort of work on a part-time basis throughout the semester if you feel that you'd have the bandwidth to do that at some point. That's also a possibility, and the possibility of taking undergraduate research credits, especially as you get into your maybe junior and senior years. Although I've done it with some sophomores as well. And so in that case, you kind of pick the number of credits you want to take, and then we kind of set up a problem that you can tackle in a semester, and then you work towards that as part of your class load, depending on what engineering program you end up with or in, or you specialize in. Then there's a certain number of credits that you may be required. If you're not required, there's also, they can be taken as electives as well.
So do we collaborate with the Formula SAE team or other competition teams? So the answer is maybe and then yes. So I'm not too sure if we help out with SAE all too much. I don't think we do, but there are quite a few of other teams that we do collaborate with. The two that come to mind right off the top of my head is Bolt. So Bolt is a fully electric racing motorcycle design team here. And I know that they work a lot with the Transportation Institute. They do a decent amount of testing on the smart road due to some of the vehicle monitoring and tracking systems that we have available. And then another team that recently kind of joined forces with the Transportation Institute is our Hyperloop team. So there are some members of the Transportation Institute that are going to be faculty mentors to the current Hyperloop team. If you're unfamiliar with what Hyperloop is, it is an advanced transportation system. It works something like a monorail, but the idea is to create a fully vacuumed out tube for you to travel in. And I think when it was originally pitched, it was pitched as a 30-minute ride from New York to LA, if they're able to figure all the math out. So I know Virginia Tech's Hyperloop team does fairly well every year in competition too. So they actually moved into the building that my desk is in. So it's nice. I get to keep an extra ear and eye on the work that they get to do.
I'll add two more. So I know we have one of our engineers works with the Baja team, and then we also have a working relationship with the hybrid electric vehicle team. Formula SAE, there's a few of us that have experience with it. Right now there's no formal agreement or I guess ties between VTI and the Formula team, but we are very much aware of what they're doing, and as I said, many of us have either participated in the team when we were undergrads or have been judges in the competitions as well. So we're fairly familiar with that. In that case, it kind of the Formula SAE team within Virginia Tech is very well organized. They've been doing this for a long time. And so they have their own space right on close to campus, and they kind of have a good system for testing that doesn't require our facilities. So there really hasn't been any need on their end to come to us and use our facilities. But we're very much aware of them and supportive as they need it. I guess. When choosing a degree in the engineering field, what advice do you have for someone that still hasn't decided on what they want to study because they like things in all of the fields? That's a good question. I think you guys coming in, it's a perfect and Jake, I'll let you talk through it because you've been through it much more recently than I have. I think at some point I was an undergrad in engineering, but don't remember very much these days. But no, in any case, so one of the good things about the way Virginia Tech does it is that for the most part, you will kind of come into a general engineering program and be exposed or have the opportunity to be exposed to a large variety of different fields. So, right now, yeah, you like a lot of things and it feels like you could pick any of them. But as you start getting more and more experience in your initial classes and whatever experiences you kind of allow yourself to have as more opportunities come your way as you're starting your studies, I think that'll help narrow things down a fair amount. If you end up still kind of not being sure, then there's some fields that tend to be broader in nature. So engineering mechanics comes to mind. It's sort of it kind of takes a little bit out of all the different kinds of engineering, and again there's a few different ones where you can go a number of different ways. Mechanical is another one, and so on and so forth. But I think you'll have opportunities to kind of explore different things, give yourself opportunity to do that, and then I think that'll help you. And then keep in mind that people like us are around. We respond to undergraduate requests all the time, so reach out to people that you think might be able to help you, and depending on what areas you might be more or less interested in. kind of see who's working in that area and reach out to them. People here are very welcoming, and they generally will give you an answer.
Yeah, so the good news is I was in that position, I guess it was 6 years ago now, which is a little scary. But the good news is there's logistics that are in place to help you right off the bat. So number one is when you come to Virginia Tech and you want to pursue engineering, you start in general engineering, where part of the coursework of your first year is to explore the different engineering disciplines to help narrow down which one you may be interested in. And part of that is exploring those in class, and then part of it is exploring those out of class. So there's, if I recall the right way, there's assignments that encourage you to go to seminars for different disciplines to get a better idea as to what the type of work that those disciplines really do address. Then some other personal advice I would add is, think about what you would like to see yourself doing, or sometimes it's just as powerful to do the opposite. What do you not want to do? And that between those two questions, you can usually get a really good feel for or at least narrow down your options, I guess is the right way to put it. The other thing to keep in mind, just like I mentioned before, since all the classes you start as a general engineer for your first year, you're taking all the same classes. Doesn't matter what you declare your discipline to be. Even through your sophomore year here, a vast majority of the engineering disciplines have very similar or the same classes. So there's a lot of opportunity. And I guess the last big emphasis, like Miguel said, is reach out to graduate students, reach out to faculty, find out what their career experiences have been, what their work experiences have been. And they're going to be your best source to really unfiltered information. Because the environment at Tech is for you to truly find what makes you happiest and what you'll succeed in most. And so those groups of people will definitely tell to you exactly how it is.
And I will tell you, from my perspective, when I was doing it a number of years ago. So I also liked a fair amount of things. I was pretty good mechanically inclined, so mechanical engineering seemed to appeal to me. But I ended up going into industrial engineering, and then taking a fair amount or most of my electives in the mechanical engineering area to kind of complement the areas that I felt the industrial engineering wasn't strong enough that I wanted to still have access to. And so that's another way of kind of doing it. Since you have a certain number of electives, you can even if you decide to go into one area, that doesn't prevent you from getting exposed to what in a bit more depth into some of the other options that are available. How common is it for students to go straight into grad school or take part in a 5-year BS MS program? Jake, I'll pass that along to you because I think you kind of sort of did it.
I technically am on paper. So it's a trick question. The answer is it's super common and then it's not that common. So let me explain. Out of the students, I guess, out of a graduating class, those that want to go to grad school is definitely, in my opinion, like less than half. So you're going to have usually, from my experience, somewhere around 25%. That's not a real number. I'm not pulling that from anywhere. That's just me taking a good guess. So you have a decent proportion of students that are interested in going to grad school. And I do feel that most, from my friends and peers, went right into grad school just to kind of keep all the schooling together. I was originally enrolled in that 5th-year master's program. And actually at Virginia Tech in engineering, you can do a direct to PhD program as well. So you can do direct to master's or direct to PhD. And for the students that go to grad school, it's appealing. If they're interested in that 5th-year master's position, they're interested in a shorter timeline, it might be really appealing. But the key there for success, if that is something that you're interested in, is I would recommend reaching out to faculty and finding research at the institution prior to getting close to that senior year range. You'll definitely help keep everything on track a little bit smoother if you make those relationships ahead of time.
Let's see, Jake, you want to walk through the 3D tour real quick? Let me.
All right, so at VTTI, we have 3 buildings. We have Building 1, Building 2, and the Automation Hub. And this is a short virtual tour of the Automation Hub. The whole goal of this building is to foster relationships between students, whether they be undergraduate or graduate, with industry partners, and get them involved in real world projects, so beyond just the scope of the university. And so here's where we start. This is the main garage bay. So there's 3 doors that you can see in the back labeled, well, there's actually 4 back there. So there's 2 little proprietary bays. So if we're working on a project that has proprietary information, those projects are stored in the bay all the way to the left and all the way to the right. But garage doors 1 through 4 go directly onto the surface street section of the smart roads. And then this door immediately to my left goes into the small parking lot for this building. So that door is just an exit door, and as we pan around, there should be a car to click on. So this is just one of the vehicles that they use for some tests. This one has some communication hardware on it, but the fun vehicle in this bay is this big yellow truck, and I believe if you click on the Garage 2 slide, the information for it will pop up. So this is the roadside vehicle, and it's a little hard to make out from this angle, but on the back of this is a vehicle crash attenuator. So what will happen is this vehicle will be parked on the side of the road ahead of construction or roadside work or maybe even a bad accident, and it'll have an arrow that will direct vehicles to move over, but then it'll have that crash attenuator lowered down so that if a vehicle isn't paying attention and veers off the roadway and hits that attenuator, it has a bigger crash cushion, and it provides another layer of safety for those that might be outside of a vehicle or inside, really, working on the side of the road. And then this other table over here, it was dedicated to a project that was using drones to help with vehicle-to-vehicle communications. And so that's just how they left their workstation when we went in and we took these pictures. But if you're wondering why there are drones here, we do work with drones sometimes. In this case, it was for just the vehicle-to-vehicle communication project, but they have been used in the past on some other more interesting projects. Then on the other side of the building is our main workspace. So we're taking a note out of Silicon Valley here, and we are using just a really collaborative open workspace. That's me at my desk. And it's really nice when you're working on a project and you get stuck or you just want to pick somebody's brain. You don't have to worry about kind of interrupting anyone because everybody's used to everybody being out in the open. It's really easy to kind of not yell, but I'll use the word yell over your desk and ask somebody for their opinion if they want to come look at a video and see what you're working on. There were 2 main groups that were working in the hub, and it was nice to get collaboration between the 2 of them. And then outside these back doors is just an example of right where the smart road is. So the automation hub sits right next to the surface streets section of the smart road. So it's really nice. You can go out if people are testing, you can look out the windows and see what they're doing. And then if you look out the other set of windows on the other side, you can see sections of the highway part of the smart road. And then lastly, we just have a little office section, a little kitchenette section. And then down this hallway, if you go straight down, you go into the garage that we were just in. But in between, we have a bunch of breakout rooms. And these, they vary in size. They vary in what else is in them, whether it be tables, chairs, whiteboards. And these are really good for small breakout meetings, conferences, you name it. And it just helps really with the dynamic workspace.
One thing that may not have been clear from all the information we've given you. So we're obviously part of Virginia Tech and very much a part of Virginia Tech, but we're actually not located on campus. All these facilities require a lot of space. So we're a few miles away from campus. There's a bus that comes over from Blacksburg Transit, or you kind of need a car to get to where we are. But Obviously, with the graduate students and faculty like myself, we were usually back and forth between campus and BTTI. The cool thing about Blacksburg is it doesn't have a lot of traffic, so it's easy enough to get around from one place to the other. I think you've seen some of on the videos. You probably saw some of the vehicles that we have. I think right now we're in all things considered, we're probably over 50 vehicles, probably closer to 100 that we can use for different kinds of experiments. Uh, and that's going to range from bicycles that we've instrumented to have people take around town and see what happens when they're riding, through mopeds, through motorcycles, to scooters. We've instrumented scooters as well. So we had a study on campus. They had I think it was the spin scooters that came in, and so we instrumented a few of them to see what trouble people got themselves into. So a couple of people fly over handlebars and things like that as they were doing that. Hopefully nobody was seriously injured, but it happened. And then all the way to passenger vehicles like what you probably drive or your parents drive, and then from there you have vans, you have short bed commercial vehicles that are more local, like the UPS trucks, to commercial tractor trailers like you would see on interstates hauling cargo, all the way to motor coaches, like big buses that would transport people either within a city or between different cities. So we have, if it moves on the surface on surface streets, we probably have at least one of them. Also, as part of our collaborations with private sponsors, usually we end up getting some vehicles that they're developing. So in that sense, it's really cool to again be exposed to some of these technologies and some of these cars before they see the light of day. I could never in my life afford a $200,000 car, but I've been in a couple of them as part of my work at the institute. So it's really neat.
Just want to pick our brains, feel free to reach out. We'd be more than happy to help in any way we can.
Well, folks, thanks for attending, and look forward to seeing you here in the fall. Take care. Have a good night.